Okay, I'm here today to talk a little bit more about the zCAT and attaching it to our optional three-dimensional software. As you know, the zCAT is the world's first truly portable direct computer control coordinate measuring machine. It weighs about 30 pounds. Right now I don't even have it plugged into power. The only cable you see attached to it is to the PC. You'll also see a screen on our computer that's showing our MK4 software. The zCAT is now also on an optional fixture stand that we offer. However, it can be just sitting right on a surface plate without a fixture, but a fixture really makes it nice for speedy measurement of parts and getting a part into place. We have all kinds of optional fixture accessories to accommodate your parts depending on the size and the shape. What I've done here is I've manually gone in and measured a plane on the top of this demonstration piece. You'll see it also created that plane on the screen. So we have simple icons at the top of the screen: circle, line, point, plane, sphere, cylinder, cone. Those are all basic geometry functions. All the operator has to do is, in this case, tell it what I'm going to measure and then manually measure that. So I've done that on the plane. So my next thing I might want to do on here is measure a line. So if I click on the line with my mouse, it brings up a window, says it's going to be unit number 2, which is a line. It numbers it here as well. Now I can physically come down here with the zCAT, with the handle of the zCAT, touch on at least 3 points on that line, and it draws that line in my window. I'm going to make that a reference for this particular part by clicking on the reference icon, and then I'll confirm it with this green check mark, and you can see it clearly drew a line on my screen. Now let's do a circle. Again, if I click on the circle icon, it tells me this is unit number 3. It is going to be a circle. I haven't taken any points yet. There's a 0 on my upper window. I can now physically come down, touch a minimum of 4 points to get a good circle, but let's go ahead and take 6 points on here. And again, it will give me the circle on here, and what I'm going to also do is make that a reference. So that will actually make the center of that circle the 0 point on this part. So as you can see, all the operator has to do is physically come in, touch on the dimensions that he wants. It will create those dimensions. Let's go ahead and do one more just to give you an idea how we can do this. Let's measure a sphere. So I'm going to click on the sphere icon, and there is a small sphere in this demo piece. You'll also notice I'm using the vertical probe right now. We'll go to the horizontal later, but all we have to do is tell the software which probe we're using. That is going to be an important step. The operator does have to tell the software which probe we're using, which stylus we're using, whether it's the vertical or the horizontal. Because this is a standard Renishaw TP20 touch probe, it sends the same signal, so we have to tell it. So in this case, again, I'm using the vertical probe. I'll come down here and start taking a few points. As soon as I have enough points, it will create, in this case, a sphere on the screen. I'll take a couple more, raise it up, and then confirm it with the question, with the check mark. So again, it's created that sphere here. You can see it in this position in a 2D mode, but let's just say that's the end of this particular program that I wanted to run. I can go to my inspection mode and hit play, and now the zCAT will go down under direct computer control and do exactly what I had done before, except now it's on a controlled speed, a controlled vector. Every probe hit is going to be taken at the same measurement speed every time. This is something I cannot do by hand, nor can any operator. We can actually edit every probe hit to be exactly at a certain point that you might want it to be taken if it's different than what we did manually. In this case, so it did the plane, made that plane a reference. It did that line, made that a reference. It's doing the circle now. It's going to make that a reference. And then it should do that sphere. It will go over. Now you'll also notice it's raising itself 20 millimeters above the part. It kind of builds its own safety zone in so it won't crash into the part. If we needed to account for something that was in the way, we can give it manual go-tos during the teach mode, and it will follow that. So that's the end of that quick program, and you can see how easy it was for me to manually go in there, measure that, and now come back and let it run under DCC. Now on the screen I can start getting my dimensions if I want. I can double click on that circle and bring it out and give me that diameter. I can also double click on that sphere and give me that. So not having done a whole lot of measurements here, there's really only 2 measurements, but I wanted to show you how easy it is to program this. And then let's talk about, in its simplest form, what it might look like in your facility. Let's say this is the part you're making. This is the type of setup that you want to measure and how you want to measure. So the operator can physically bring the part up, put it in location. This could be part number 2, but let's say we already have a program written for this. So I'm going to delete this particular program I started to write, open up a file that could have literally thousands of programs. In this case, I've written a program earlier today called Big Test Vertical, because I'm going to use the vertical probe again. So I'm just going to double click on that program, and you'll see it brings up another image of this particular part in how I had programmed it earlier. So the operators can bring up the program, in its simplest form, just put it into location, and I can just hit the play button, and I don't have to do anything manually at this point in time. It's going to do exactly what I had programmed it yesterday, or last week, or last month. Not only is it going to do that, but it's going to archive the data. It can create a chart, if you will. Here I actually gave it a go-to up above that because I am measuring a plane, and I wanted to compensate for that cylinder that was coming up out of the part. So I measured a plane, I made that a reference. Then I went over and I measured this line on the side of the part, and I made that a reference as well. Now, since we have a fixture with a perfect location, some of this is not really even necessary if I wasn't concerned with that. But I am, so I went ahead and I measured this diameter again. So these are going to be some of the same features we did before, but again, I could have written this program last month, and we started to run this part again, so I brought it up. And now the operator obviously isn't going to be walking you through all of this. He's going to go do his job while the zCAT is doing his job in measuring this part. So now it's measuring the bottom of the part. On the screen it will update that angle that we called out. Now it's going in measuring a diameter. Again, on the screen you can see it highlights in green where it's measuring. There's a small red dot that shows exactly where the probe is. When it's finished, it will update the diameter of that hole. Now it's going to go over and measure this cone, and again it's highlighting it in green. It's taking multiple probe hits in different positions around that cone, and as soon as it's finished, it will update our numbers here. It was 60.01. We'll see what the next one is when it's finished. 59.964. So now it's doing the sphere again. It's going through the different sequences of doing. I've done planes, I've done lines, I've done cones, I've done cylinders, I'm doing spheres. So we can also construct points off of this. We could construct a line where that cone would intersect with the plane. We could construct a line where 2 planes intersect. We can construct a point where 2 lines intersect. You can do all the things you can do with a CMM. We're taking literally hundreds of points. We can measure dozens of features and do it all under DCC. While the zCAT is doing its work, the operator could be doing something else, getting the next part ready. That's how it's finished. Now I could theoretically take this part out, put the next part in, and hit play again. Or let's say we wanted to start using the horizontal probe. And you know from the zCAT, it has both a vertical and a horizontal probe. This probe will rotate 360 degrees. So if I can touch it, I can measure it. So let's say I wanted to measure the same part, but I wanted to do it in a horizontal fashion, like this. So I could come in here and measure features using the horizontal probe. I just happen to have written it. I can save this data on this program. I can go back until I want to open another program. In this case, I'll do the horizontal probe. I'll double click on it. And now it brings up a different program on the same part to measure some dimensions using the horizontal probe. So I'll just get the zCAT in position, and all I'll do as an operator is hit the play button. You'll see that it switched to the horizontal probe on the screen. It also switched to horizontal probe 1, and now it's going to measure a lot of the same features using the horizontal probe. Now it's measuring a plane, because when we're using the zCAT or any other CMM, when you start measuring diameters and cones and lines, it likes to reference off of a plane. So the first thing I do a lot of times is measure a plane so I can reference off that. Here I actually measured another plane on the top of that cylinder, and now I told it to measure the outside diameter of that cylinder. And again, we're using strictly the horizontal probe. So we're doing a lot of the same things we did before, but a lot of parts we can't touch everything with the vertical probe, so we want to use the horizontal probe. Now I'm actually doing a cylinder on the inside of that. You can do a cylinder on the outside or the inside. In this case, just for demonstration purposes, I'm doing a cylinder on the inside. I did a diameter on the outside. The next dimension is going to do that same sphere we did, but again, we're only using the horizontal probe. But it's the same process. We're going to go in the first time, manually teach it where to take points, and now it's repeating it and archiving the data. It's doing simple statistics in the background as well. Those can be called up at a later time. Now it's going to go down, it's going to do that cone again using the horizontal probe. And again, we could be doing a lot more features in this, but you know, for demonstration purposes, I just want to give you the idea of how this would work with both the vertical probe and the horizontal probe. But let's say in this part, we actually want to go around and measure on the other side as well. So what I've done is I've programmed it to come around and measure a plane on the front of the part. So you see the probe rotates about 90 degrees and comes in and measuring this plane on this side of the part. And then I had it rotate around and measure a plane on the opposite side of the part. So you can rotate it 360 degrees, measure on all sides of parts. We can even, if the part is up, raised up on a fixture, we can even go underneath the part and measure a plane on the bottom of the part if it's set up that way. So that's a very simple program to do a lot of the same features, only using the horizontal probe. And again, you'll see on the screen everything was updated. We can even go in and look at some of the dimensions here. If I right click on one of them, I can bring up a lot of information about that part, all the different ones that I measured. It can build its own chart on the results of those measurements over time. I could delete that, start over again, but I won't lose the program. All I do is lose the old data. So there's a lot of capabilities here that you don't have by using standard hand tools or other equipment used on a surface plate like this, because once the program is written, we get the part in place. All the operator has to do is hit play. He can go on to other duties, and the zCAT is measuring it all within microns and repeatable within microns. So that's a simple demonstration of the zCAT using its MK4 software. If you'd like a full demonstration, we're available to come in and do demonstrations at your facility. We also are available to do demonstrations, live demonstrations online on your parts if you send them. Otherwise, we can do it on demo parts and give you an idea of how it would work. All the time giving you an idea how you can advance your measurement process for almost any one of your operators to learn how to use a zCAT in a very short period of time.
Working harder.